Hello and welcome to my video, lesson 7.5 on modeling and solving systems, specifically linear systems of equations. So we just have a bunch of different word problems to take a look at for this lesson. It's all the same skills as the rest of the Learning Guide 7 unit, but there's word problems. So you have to first create the two equations and then you can solve them using all the other skills that we've already used and perfected over the course of the unit. So we are going to start with that first question. If you can pause the video, try this question and the second question, and then see if you get the same answers that I do, that would be great. Okay, so reading it very carefully, we have to be, again, very careful to make sure we write down the equations for these. So sum of two numbers and 3 is 4 times the first number. So the sum of two numbers, so a plus b and 3, so plus 3, is, so it's equals 4 times the first number, so 4 times a. Okay, that's our first equation. Our second equation is the larger number minus 1. Oh, I guess, I don't know if that larger really matters here. But anyways, one of the numbers, minus 1, equals double the smaller number, 2b. I mean, like, it is going to be larger given that it's 2b, but it doesn't really matter too much. Okay, so here are our two equations. Now we need to rearrange them and solve for a and b. So in this red equation, we can solve this for a, first of all. So if we add 1 to both sides, we get 2b plus 1. Now that we have that, we can substitute it in for a over here and for a over here. So it would be, 2b plus 1 plus b plus 3 equals 4, and then a, which is 2b plus 1. Okay, now we're going to slowly rearrange this and solve for b. So there are 3 b's on this side and 4, and this is 8 b's on this side plus 4. I have a feeling like this can be 0, so this might not make any sense. But let's try to move this around. So let's subtract 3b on both sides. I think we're only going to have one solution that makes any sense. And subtract 4 on both sides. So we're left with 0 on the left and 5b on the right. Oh, look at that. Yep, we're only going to have one solution that makes any sense. So then you can divide by 5 on both sides. So b equals 0. And if b equals 0, then we can substitute that value back into b over here. And so we're left with a equals 2b, which is 0, plus 1. So a equals 1. Now, you can verify this by plugging both those values back into the first situation and into the second situation and see if it works. And if you check that, it will. You don't need to verify unless the question says verify, but if you did, you could see that would work. So 0 and 1. Okay, let's continue on to our second question. Again, you can pause the video and try doing these questions yourself. Okay, the perimeter of a rectangle is 44 centimeters. if the length is triple the sum of the width plus 2, and 2, find the dimensions of the rectangle. So perimeter equals 44. Now perimeter also means 2 times the width plus 2 times the length. If you draw this out, if you draw out the rectangle, maybe, hopefully you can see that, we'd have 2 widths and 2 lengths that we have to add together to get the perimeter. So that is our equation. We can kind of ignore this part now, and we have an equation with 2 letters, 2 variables in it. If the length is triple the sum of the width and 2, so plus 2, find the dimensions of the rectangle. So there are 2 equations in red and in blue. So now we need to solve for one and substitute in the other. Now the red one, it's already solved for L, so we may as well just simplify it and now substitute it in. So this is L here, so we're going to substitute it over here. So we have 44 equals 2W plus 2L, where L is the 3W plus 6 that we just solved for in red. Now we have 44 equals 2W plus 6W plus 12. We're going to move the 12 over by subtracting by 12 on both sides. And we're going to, so we'll get 32 here. And we're also going to add the W's together, so we get 8W equals 32. Now we're going to divide by 8 on both sides, and we get that W equals 4. So this is great, but we're not quite done because now we need to substitute it back into the red equation. So L equals 3W, which is 4, plus 6. So now we can solve this for L, so it's going to be 12 plus 6, which is 18. So L equals 18, W equals 4. And those are our 2 answers. Awesome. Okay, 2 more questions. Again, pause the video, try it out yourself, and see if you get the right answer. Okay, so we need to read this very carefully. The bank has a bonus for signing up for one of their mutual funds of $300, but their accounts have historically only produced a return on investment of 8%. The choice is to take this deal or to invest using an ETF which has a historical return of 10%. If you have $5,000 to invest, how long would you have to wait for the ETF to surpass the mutual fund? Okay, this is a real life situation that I actually went through just a couple years ago. I mean, the dollars are not exactly correct and the percentages are not exactly correct, but they're close, okay? I don't remember what the numbers were, but it was close to this. So anyways, we're going to invest these different amounts and we're going to see what happens. How does an investment work? Basically, we're going to do a simple interest. Okay, there is compound interest, but that becomes too complicated for the purposes of linear functions. So we're doing simple interest of that and of that. So just keep that in mind. So $5,000. So what you want is the amount at the end. Okay. So that part is what we're looking for. Now, the first situation is you have $300 as a bonus, plus you have $5,000 times by the interest rate, which is the 0.08%. So this is going to tell you the amount of, actually I'm going to use I for interest. Okay? But this interest rate happens per year. So I'm going to put a T for time here, or Y for year, actually. Okay, so this is the first situation. The second situation is also I for interest, but there is no bonus, but it is a faster rate. So this is going to be 10% per year. Okay, again, this is simple interest, so it's not exactly correct. It'll be close, but it's going to be even more exaggerated for the red one, and the red one will beat the blue one earlier than what we're actually doing right now with compound interest. Compound interest is quite an amazing thing, actually. So anyways, now that we have this, we're going to substitute this one into this one. So we're going to have 5,000 times 0.10y equals 300 plus 5,000 times 0.08y. Now we need to solve for y. And we can do this algebraically, but it takes time, but we'll do it anyway. So 500y equals 300 plus, and then 80% of that, so 400? Yeah, 400y. Was able to do that in my head. Okay, and then we're going to solve for y, so we're going to move the y's over. So we're going to subtract by 400y on both sides, so we get 100y equals 300. Then you're going to divide by 100 on both sides, so then we get 3. So it's going to take 3 years, 3 years, right, that you'd have to wait to catch up. Okay? Now, there could be a part B to this question that would say something like, okay, which just would mean basically that we're just going to take that value and substitute it back into one of these formulas to solve for I. So this is going to get us the interest though. Okay, so we already figured out that this is going to be 500, y, which is 3. So we're going to get $1,500 or $1,500. Now this is $1,500 in interest. So how much money would you have at that time? You would have $6,500. Okay, so it is a little bit of an interesting question. Now we are going to show this one just because it's one of the ones that's a little bit more obvious. We're going to show it on the graphing calculator, and we're going to graph the original red equation and the original blue equation. Okay, so I've adjusted my Windows settings. I put my y max to be 2000, my y equals to be the two different equations. The red and the blue line up exactly with what I've written there. And you can see that the red one starts off at 0 bonus, but after 3 years, it manages to surpass the blue equation. So even though there's a $300 bonus, that blue mutual fund equation is actually worse. Now this is historical return, so in real life it doesn't always work out like this, but roughly it does. So second function, calc, intersect, we're going to move over to that intersect, press enter, 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 and that is the same value that we got here on paper, with algebraic processes. Okay, so honestly, if the equation is already solved for, and I'm just going to point at it here, if it's solved for one letter already, graphing it is the easiest way. If you graph it, I want you to draw a quick, simple picture of what that graph looks like. So, for example, this is kind of what my graph looks like. I mean, it's not perfect, right? But you can kind of see here that this is my intersect, and it is at the point 3, 1,500. And so that would be a very good way of showing showing your work for a graphical question. 0 to 2000, 0 to 5. Okay, that's kind of what I would do if you're to draw it graphically instead of doing an algebraic process on a word problem. Okay, here is one more question to try out for this lesson. Bob and Alice went to a bookstore and bought some books and notebooks. Bob bought 3 books and 2 notebooks, spending a total of $82.50. Alice bought 2 books and 4 notebooks, spending a total of $75. Find the cost of 1 book and 1 notebook. This is a very common type of question as well. In fact, ChatGPT helped me create this one, although it was making something a little bit wonky, so I had to fix it up. But anyways, basically, here's the thing. Bob bought 3 books, 3B, and 2 notebooks, so plus 2N, spending a total of $82.50. So this is Bob's purchases. That's the first situation. Alice bought 2 books and 4 notebooks, so plus 4N, 4 notebooks, spending a total of $75. Okay, find the cost of 1 book and 1 notebook. So this is the equation written from there. Now we're going to solve this for B and solve this for N. You can pick which one you want to do. I'm going to do the red equation, and I'm going to solve for B. So actually I'm going to use like this. 2B equals, I'm going to subtract 4N on both sides. So it's going to look like that. Then I'm going to divide by 2 on both sides. So this is going to be 37.5 minus 2N. Okay, now that I have that, I can substitute that back into the blue equation. Okay, so the blue equation would give me 37.5 minus 2N plus 2N equals 82.50. So this is my blue equation with that orange part substituted in. Now we can multiply that out, which would be 112.5 minus 6N plus 2N equals 82.5. Now we can simplify this a little bit, so 112.5 minus 4N equals 82.5. Now we can add the 4N to both sides, which I would prefer if I wrote it like this. Okay, now I can subtract 82.5 from both sides. So we'll have 30 on the left and 4N on the right. Is that correct? Yes. And then you divide by 4 on both sides. Now that's not going to be an even number. So 7.5. Okay, so that is our N value. Now that we have our N value, you can substitute it back into the orange and solve for B. So B equals 37.5 minus 2N, which is 7.5. Okay, and so we get B equals 37.5 minus 15, which means B equals, it's just going to be faster if I do this, minus 15, so B equals 22.5. Alright, so yeah, that is a bunch of word problems for systems of linear equations. I hope this video helps you better understand those. Like I always say, practice makes perfect. So practice more and more of these questions if you can, and see if you can figure them out. Hope this video helped, and good luck.